So it's not that time travel is easy, it's that it's achievable. Forward time travel with the right velocity has been possible for some time. Going back in time is possible once we realize that c changes for each space-time medium. Other than that, in each space-time medium, c is an obstacle, much like a Chinese finger trick. The harder you try to achieve c, the more impossible it actually becomes. The chart was made by Lorentz, and it reflects the parabolic curve of velocity and time dilation as you approach c. So basically, this direction is velocity, this is the speed of light, this is how much time changes. It basically is like the mass increasing as you approach the speed of light. It increases toward infinity. And in this case, time dilation is very mundane at slower speeds, even at half the speed of light. And it isn't until somewhere over 90% of the speed of light that you start getting a bigger fraction of dilation. So dilation exists every step of the way, but doesn't really start increasing until you get very close to the speed of light, relatively speaking. 95% is really where you start measuring somewhere around 33% time distortion. So you can see in all the examples that we're even using where 1 day versus 2 days would be extremely high speeds and would take a lot of energy to reach those speeds. And this makes the change in c extremely relevant because basically, if you think of c as a matter velocity wall, that in any space-time medium, your c acts as a barrier. So by existing and traveling in a different medium of space-time, for instance, we've got the string theory level medium, atomic level, molecular level, cellular level, and we've got the point where we get to our space-time, which is the solocule. And the solocule space-time, if it can be changed to a lesser consistency, then that would take this chart and make it the defining factor for why you could accelerate to a fraction of c in one medium that exceeds c in another. So the key to time travel, forward or backward, is cheating the medium. Our swimmer here in the swimming pool is limited to c in this analogy, okay? So this is light. That's what limits the whole velocity, is how fast can we go compared to c in our medium. So what our swimmer does is basically clears the medium. Okay, so you got water, you got air, you got water, and you do that with a blast of some sort. It doesn't matter. You blast that water out of the way fast enough to go through where the water isn't before it can come back, and you exceed your limiting factor and you've time traveled. So moving forward, we'll talk design and logistics of forward travel in the space-time and going back in space-time, different paradoxes, different considerations. What did it actually take to go back to 1870, and what will it take to land back in 2017 accurately and safely? So I appreciate you going with me on this journey. More from 2017 on design and logistics of space travel. So just to get you to exactly how we ended up doing it, took my idea of pushing the swimming pool water out of the way and blasting through, and was kind of laughed at by the jet propulsion guys. But as it was, we did strike on a design based on that concept. And instead of having to travel out into outer space and come back, which is very impractical, we decided that this could be done in a circle, and that instead of having to create some sort of tunnel for a craft to travel through where space-time material is displaced or changed, that it could be done in a loop. So the swimming pool idea actually kind of held. When you look at what we do to time travel, it's actually like a upright, large, round swimming pool And the craft that we devised basically uses plasma propulsion, which pushes space-time material out these slots, and we can basically run the drive until the space-time material is what we need it to be. So the space-time material decreases to the density that we need it to be based on our calculations. As far as traveling to the future, much easier, because you can travel at a very high fraction of the speed of light, c, or solicule. So the solicule speed of light, you can get up to 95% of it, because we adjust our space-time material so that we're running like 30% of c in this medium, and that 30% of c in this medium puts me at 95% of the SC, which allows future travel. Very, very easy. But traveling to the past is far more complicated as far as the calculations. I don't pretend to know how to do that math, and in order to go back in time and come back, I definitely rely on those professionals. But I do understand the concept. We're adjusting the space-time material to a necessary and appropriate level. We're, in this case, exceeding solicule C dramatically in some cases. So to go back to 1870, we're exceeding it by double for a few minutes, and that's what happens. So basically, the good news is you can go back and forward in time, and basically my existence, reality, and frequency and perception of time, my days going by have remained the same. It's exciting, and I'm glad to bring this concept to you.